Hello everyone, I'm João from That's Brilliant. In this video you're going to see the Newton's second law of motion. So if you didn't watch the Newton's first law of motion video of That's Brilliant, I'm going to put the link of that video in the description of this video. Watch it because it's very important to understand this second law. Because the second law is very related to the first one. And we saw in the first one that a body tends to remain with the same velocity if a net force applied over it is equal to 0. So if there is no net force over a body, the body tends to remain or in a state of rest or moving in a straight line with a constant speed. So if the net force over a body is equal to 0, the velocity tends to remain the same, tends to do not change. But if the net force applied over a body is different from 0, the velocity is going to change. This means that the body is going to accelerate. And this is exactly what the Newton's second law of motion says. If the net force over a body is different from 0, the body is going to accelerate. But how much it's going to accelerate? So let's deduce an equation that we can use to measure the acceleration or the force. So let's see, imagine you have here a tennis ball and a basketball. So of course it's obvious that the tennis ball has less mass than the basketball. And let me write here what I just said. If the net force over a body is different from 0, the body is going to accelerate. This means the velocity is going to change. The body is going to accelerate. So let's see, imagine you have the tennis ball and the basketball, and you make the same force. You apply the same force in the basketball and in the tennis ball. Well, what ball is going to move further, or what ball is going to accelerate the most? It's kind of obvious that it's going to be the tennis ball. It's going to accelerate more than the basketball if you apply the same force to both of them, because the tennis ball has less inertia, has less that tendency we saw with the first law. So the tennis ball has less mass, less inertia, so it's going to be more accelerated than the basketball. And with this we can see that if you apply the same force, the greater the mass, the lowest the acceleration, because the basketball has more mass and accelerates less than the tennis ball because it has more inertia. So we can see that mass and acceleration are inversely proportional quantities. So if the mass increases, the acceleration decreases. And now let's think, you want the same acceleration to the tennis ball and to the basketball. You want both of them to accelerate in the same rate. In which ball you have to apply more force? And it's a little bit obvious that is to the basketball because it has more inertia. So you have to apply a greater force to have the same acceleration that a lowest force can give to the tennis ball. So if you want the tennis ball to accelerate the same thing than the basketball, you need less force to the tennis ball because it has less inertia. So you can see that the greater the mass, the greater is going to be the greater is going to be the force, because if you have more mass you have more inertia, so you have to have more force to accelerate that body. So you can see that mass and force are directly proportional quantities. And using this, we can deduce that equation I said. Because you see that if the mass increases, the acceleration decreases. The mass increases, the force also increases. So you can say that mass is equals to force over acceleration. Imagine that you have here a division. If the acceleration increases, this result of the division here is going to be lower. So if the mass increases, the acceleration decreases. If the mass increases, the force increases. If you put here, if you conserve this number and you put a higher number here to the force, the mass is going to be bigger. It's just a simple division. And you can multiply both sides by acceleration, and you're going to see that force is equals to mass multiplied by acceleration. And this is the Newton's second law of motion. You can put this here in this way, or using vectors to represent the equation. So you can put vector as a vector to the force and a vector to acceleration. Mass isn't a vector quantity. And this is the Newton's second law of motion. So if you have a net force over a body, it's going to accelerate. It's going to accelerate. When the net force becomes equal to 0, the acceleration stops in that moment, and the velocity that the body had in the last moment of acceleration is going to preserve while the net force is equal to 0. So this is basically the Newton's second law of motion. Now, units to this equation. You're going to mass in the international system of units. Mass is going to be measured in kilograms, and acceleration is going to be measured as meters per second squared. So which unit we give to force? Well, we're going to use N for Newton. The unit of force is Newton, just to honor Isaac Newton, who is the between brackets, between commas, the creator of the laws of motion. He was very important to physics, so to honor him, we put Newton as unit of force. So what is 1 Newton? 1 Newton is the necessary force to accelerate a body that has 1 kilogram of mass at a rate of 1 meter per second squared. So this is 1 Newton. So this is it. This is the Newton's second law of motion. If you have any questions, please leave them down in the comments below. Thanks very much for watching, and I see you in the next videos.